for me, not only to share a lot of what I'm very passionate about, but also to hear you starting to skin think, which I translate into skinking. But I'm glad that you are skinking at the moment, because I would like you to leave here with my one aim was to make you more aware of what is out there, of our own skins, obviously. But more importantly, I really would like you to translate whatever you've learned, whatever you've grabbed, whatever has grabbed you this week, to other people. And so the challenge is laid down to you, just to share something of what we did this week with one other person outside of this room. And so whether it is your grandson, your granddaughter, your daughter, your son, your partner that may not be here, your grandmother, whoever, just share something that grabbed you this week that you may not have known, or that you did know but you were reminded of. And so the aim was really to just enlighten you a little bit more and to get us thinking. So thank you. I've also included, so let me just tell you one or two technical things before we start. The one thing is that I will provide the lecture series as a PDF package to the summer school. It'll go on the website, so keep your eye on the website. Obviously, give them a few days. It is not going to appear on Monday. Okay, they need quite a few days to put all the lectures and everything together, all the packages. But it will be on the website. I will also include, as I promised yesterday, the links for quite a few of our publications on that. And obviously, you have my details. So my details, and really I want to encourage you to, if you can contribute or keep in contact in any way, via email is probably the best. I don't tend to give people my cell phone numbers, sorry. But, and I will certainly get back to you. I may not get back immediately, but I certainly pick up the emails, and I'm on my email just about all the time. So thank you for that. What I want to share today is a little bit of the HOPE research that we're doing, linking it to vitiligo, burns, and cancer. And so we'll talk a little bit about that. The one question that was raised was the glare off the front screen. Are people struggling to see my texts on the screen because of the glare? Unfortunately, the problem is we don't have a dimmer on these lights. The age of this lecture theatre, which is probably older than I am, does not allow us to dim these lights, which we tried. So we'd have to switch off the entire lights in the whole lecture theatre, and then you won't be able to read, or you won't be able to write, or read what you're writing. So if you don't mind, we are going to leave it on, and then you can just, if you do have a problem. By the way, the writing on that tunnel is blurred. Okay, so it is, and I wanted to read it to you. It's a wonderful quote. The light at the end of the tunnel is not an illusion. The tunnel is, and I thought it's a great quote to kick off this morning, because we often think that it is a lot more difficult to try to solve something with just a little bit more thought. We actually have the solution. We just have to sort of get into it and try to solve it. Then there's been very good news, and this came across my email yesterday, that Virgin Active is saying goodbye to their sunbeds as of the 1st of April. I'm sure it's not an April Fool's joke. I will check though. But from the 1st of April 2017, they're removing all their sunbeds from all the Virgin Active clubs all over South Africa. And they will no longer have indoor tanning facilities. So that's, yes, one for us. So this morning I want to kick off with vitiligo again. You've heard more than enough by now about vitiligo, but I want to tell you the story of how we managed to change a 12-year-old's life. This is the son of a colleague of mine, and he has vitiligo, and he has symmetrical vitiligo, so you can see it's on both knees. He's 12 years old, of Indian descent, and very active little boy, beautiful little boy. He plays soccer, he plays cricket, he plays rugby, just about anything that he can get his hands on, he plays. Unfortunately, because of his vitiligo, lots of his areas are under high stress, under high stress in terms of abrasiveness. And so he gets vitiligo, and his vitiligo started as a small spot and then continued under the more abrasive areas. His knees, his elbows, his hands, and his feet. And then he started getting spots on his neck as well, where his shirt collar used to rub against. And those are very often the types of issues that activate vitiligo, because you're generating stress on the skin in that area of abrasion, and the melanocytes, which are suspicious anyway and susceptible to dying, they tend to die. In the Indian community and in the Muslim community, interestingly enough, when they do have vitiligo, it very often starts under their neck, in the neck, just under their chin, sorry. And what we found was that they were tying their scarves quite tight around their heads, and that the buckle was over here. And that shaving on the underside started the vitiligo spot. And from there, it spread. So this little boy, he came to us, and we decided via my lab that we would conduct a study to try to get his cells, his normal cells, clone them, and then add them, return them to the vitelliginous areas. Okay? And so it was quite an ambitious thought, but we thought that we were skilled enough to be able to do it. So we brought him into surgery. We took a couple of biopsies from a normal area, and what we normally do is we take a biopsy so that you don't even see it. It's a 2-millimeter biopsy, so it's tiny. It doesn't hardly even needs a stitch to close up. But we take punch biopsies. We took a few. We took it back to the lab, and this is what we did in a nutshell. Okay, we call it cloned human cell transplantation. We took an area that has not been affected by vitiligo, and we take the whole skin. We take the whole skin as a block. We drop it into an enzymatic solution that actually breaks up the skin into its individual cells. And so we break down all the connections between the cells without damaging the cells themselves, and that's a critical part. We then take out the melanocytes, the keratinocytes, and that third cell type that I told you about, the fibroblasts, because even though we only take the epidermis and we're only really interested in the cells of the epidermis, you naturally, when you take a biopsy, you get the fibroblasts as well. They tend to be a bit irritating because they tend to outgrow the melanocytes and keratinocytes, so we normally kill them off. But in this case, we kept them, and then we separate out the cells into the 3 different cell types. And the critical part, or the clever part, is that what we grow these cells in is an enhanced solution for their specific growth. What do I mean by that? By that I mean that melanocytes grow in a solution, keratinocytes grow in a very different solution, and fibroblasts grow in a very different solution. So when you try to recapitulate the environment of the skin in a lab, it is very different to these cells all living happily next to each other in the skin, where they're exposed to the same things. And that one sentence growing these cells separately in order to propagate them, in order to get them more and more and more, has taken us about 4.5 years. Okay, just that sentence. So we now know how to grow them up. And this is a little bit, I'm going to just hit the lights, if you don't mind, for 1 second, just to show you, because it'll be a little bit better to see. By day 3, when we take that biopsy, by day 3, and this is a photograph off the microscope of a cell culture, right? We call them cell cultures. And what you can see is that all these light specks, and let me just describe it to you, all these lighter areas are actually nuclei of cells, of single cells, okay? So that's a cell, 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 that's a cell. And if you're nearer the front, or if your eyes are pretty good, you can actually see that some of them have these irradiating lines coming off them, which denotes them as melanocytes, because those are the dendrites. You remember that hand that I told you about, right? So the light part is the nucleus, okay, and these stripes coming off it, the spicules, are the dendrites. And so we know that we've got melanocytes. The keratinocytes in between are quite difficult to see because they're translucent. So they don't have that much melanin in it on the microscope for us to see it that easily, but they are there. By day 10, we have now separated out the melanocytes and the keratinocytes. And so we're growing pure melanocytes now, and we're growing pure keratinocytes. And I'll show you a bit later what the keratinocytes look like. But we were concentrating in this study, we were concentrating on the melanocytes because it is the melanocytes that are dying off in vitiligo, right? So we just wanted to propagate these melanocytes as much as we could so that we could get it back onto the kid. And this is, after 10 days, we've now increased the numbers of melanocytes, and you can see them. If this is called the phase contrast, so that you can just see the cell. If you were to switch the microscope onto, and you actually had a white background of the microscope, I don't have a picture, but the picture that I showed you much earlier in the week, where you actually saw the black melanocytes with the arms, you'd be able to see that pretty much like that. By day 15, we now have an entire, and this is a slightly higher magnification on the right here, we have an entire culture of these beautiful looking melanocytes, okay? Very healthy, large nuclei, beautiful dendrites stretching everywhere, and those are healthy cells. Okay, so then what do? We took him into surgery, and we debrided. So we took off the epidermis and slightly lower into the dermis, and we knew that because as soon as we eat the blood, as I told you with the tattoos, as soon as we eat the blood, we know we're pretty much near the dermis. This is a little debrider machine, which is really a little drill with some sandpaper on the end of it. And so we take off the epidermis in and around the vitelliginous areas, okay? Now we have a surface that is just about ready to accept cells. And of course, this is all done sterilely. We have to take him into surgery. He gets some lignocaine in and around these areas so that we don't need to knock him out totally. We just deaden the areas that we're going to do. That's my hand, with the cells that we've now grown over the last 2 weeks, okay, that I showed you. And if you look at the numbers, because we can count cells, right? We do that all the time. We started with 80,000 cells, and this is 80,000 cells out of a mixed biopsy. So it's a combination of melanocytes, keratinocytes, and fibroblasts. We started with 80. We ended up with 1.2 million pure melanocytes after 13 days, and that's 15 times the amount of cells that we started with. So within 15 days, we produced roughly 15 times the amount of cells that we originally had. We can then suck them up very gently, and we go into surgery after they've debrided, and we drop these cells, highly concentrated drops of cells, onto the wounded area, right? We've wounded it. So it's onto the wounded area, and then the trick is to use a very good absorptive cloth, or it's a surgical gauze to place over the wound so that the cells don't run away, okay? Because remember, you're not working with a very flat surface, you're working with just under the knee, so it's very uneven, and you don't want the cells to run off. And so we cover it with this gauze, which is a clinical gauze, and over time, what happens is that the gauze will eventually dry up. The cells actually sit and adhere onto the skin surface, because that's how we prepared it, and the gauze eventually falls off, okay? But at least the cells are there, or that's what we hope. So 11 days post-procedure was like Christmas for us, because we had to start unwrapping his knees. And so that is what he looks like 5 months later, okay? 5 months later. And that is the before picture, and that is the after picture. 6.5 months later, that is what his knees look like. And that is just off one procedure. So we were pretty happy that he started to repigment, and these areas are all new pigment, and as you can see, it's a little bit lighter brown than his actual skin, but over time, with the sun exposure, etc., it eventually sort of fuses into his normal skin color. And so about a year later, he was fully repigmented in the areas that we actually did. Unfortunately, we didn't do another round, and so now, 3 years, I think 2.5 years later, he's already started to depigment again, because those areas remain under high abrasive conditions. And so really, he's also going for therapy, but the therapy is not working that well. But we hope to, in the future, probably in the next year, try to do another bout, and hopefully we'll be able to repigment him even more. But I think we did a decent job with him right there. So this was just a summary of what we did, and the most important point is the last point, that because of the success of that story, we now are just about ready to launch a study at Red Cross Children's Hospital, where we're going to translate this technique into the burns patients. And we've got the study. It's ethically approved through UCT and through dermatology, etc., and through Red Cross. And we're just about to start it, where the plan is to take 5 kids and do autologous of the body, autologous cell transplantation, via the same way that we did in the vitiligo. And I remind you, this was the picture that I showed you yesterday, that it does look exceptionally similar to vitiligo, right? And so we're looking forward to, well, we're not looking forward to somebody getting burnt, but we're looking forward to trying to translate our knowledge of what we know to these kids, that we can help them and hopefully restore their original color. This we call the healing triumvirate of cell types, and so the melanocytes, and so these are what the keratinocytes look like under the microscope, that I didn't show you. We have the ability, as I said, to separate them out, to grow them separately, and then to reconstitute them, and to recapitulate the three-dimensional aspect of the skin. So the methodology is the same, except now we want to, in the case of the vitiligo, we used melanocytes because we needed to restore the pigment. In the case of a burn wound, we want to restore the entire skin. So we need the melanocytes as well as the keratinocytes. And what has taken a PhD student of mine 3.5 years to figure out is what kind of ratios these cells sit in the skin, in the epidermis. So remember, we started by saying, I was explaining to you that 1 melanocyte to 6 keratinocytes in the basal layer of the skin, and 1 melanocyte to about 36 keratinocytes in the upper layers as we go up. And so when you reconstitute these cells onto skin, when you want to recapitulate skin, those are exceptionally important ratios to try to work out. Because if you differ in the ratios and the body does not like it, they're going to kill off the melanocytes, and then you have no more ratios, and then things just go all right. So he spent about 3.5 years in culture taking cells and adding them in different ratios and looking at the repigmentation status, whether the melanocytes actually act like normal, whether they are repigmenting, what they like, what they don't like, the keratinocytes, whether if we add enough keratinocytes, if we add too little keratinocytes, what happens? All of that, 3.5 years translated into a PhD. So in this case, we want to reconstitute keratinocytes, fibroblasts, and melanocytes. But more than that, we need to know, I said to you that the keratinocytes and the melanocytes grow in very specific fluids themselves, separately. In this case, we need to translate it into finding a fluid that they are happy with, the keratinocytes and the melanocytes, and possibly the fibroblasts, but one fluid. Because you need to grow them up as one culture to put them back. And so that was another 1.5 years of work where we were trying to understand whether we can take some of that fluid and some of this fluid and some of the fibroblast fluid, mix them up in different ratios, add different things, takes a very long time, add different things and watch the cells and actually see whether the melanocytes are acting like melanocytes. So the last thing you want is for the melanocyte to change, okay? Number one, you want it to act normally. You do not want it to get out of control in terms of cell proliferation and, God forbid that it becomes a melanoma, which you have to guard against. You also have to do the same with the keratinocytes. You don't want them to become carcinogenic. And so you have to keep a hand on, when you're growing them, that they're actually growing at a rate that matches the way the body would normally grow, okay? As soon as they grow out of control, you ditch them, you start again. So just to give you a little bit of inkling into what we do every day as researchers, we don't just sit and read papers with our coffee. So those are the type of questions that we needed to address. And we were very happy because in the end, sort of about 1 year ago, we started producing these beautiful, what we call co-cultures. Okay? Co-cultures, melanocytes, keratinocytes in different ratios, and the most exciting thing for us was that we could also see that the pigmentation of the melanocyte was happy because it was actually pigmenting the cultures. Okay? And as we upped the ratios, we could control how much pigmentation was actually being made. So if you varied the ratio slightly, and if you varied the conditions slightly, you could actually almost direct the melanocytes to produce a certain amount of pigment. Okay? That information, unfortunately, is patented by my lab, but it is important to know that if you're putting these cells as co-cultures onto a fair skin, you don't need that much pigmentation. If you're putting it on a brown skin, you need slightly more, and if you're putting it on a black skin, you need even more. And so very often you cannot rely on the surrounding skin to enhance it so that it actually gives that pigmentation. And so unfortunately then you're left with what these patients are left with now, which is a completely healed skin but completely depigmented, okay? Or pink, or a lot lighter shade than the original color. And so going forward, our research is now going to be driven in the direction of, we now know how to co-culture these cells, we now know how to put them back onto the patients. What we now need to do is work on restoring the original color together with healing the wounds. So watch this space. I just want to show you the other thing that we've been working on. It is very difficult when they brought Pippi's skin back from Genzyme. They could only bring it back as a dual sheet of cells. So basically, they took the keratinocytes and the melanocytes. They were not really that interested in the melanocytes. So they were not really interested in giving her pigmentary status. The main aim for them was that she would be healed, that the skin was a healed skin. They could worry about the pigmentation later. In any case, she was a lot fairer, so you didn't need to worry that much. Of course, Siliwe Mashego was a very different story. But even in her case, they rather concentrated on getting the keratinocyte sheets back to South Africa than keratinocytes plus melanocytes. And so we've improved on that a little bit in trying to replicate not only the melanocytes, the keratinocyte sheet, but also the melanocytes in it, so that we can restore the color. However, we've also been working on a three-dimensional cultured transplantation, and this is actually transplanting a whole skin that you recapitulate in the lab onto a patient. So, and this was the lab experiment. So let me just explain very quickly. In the top left, you start the experiment by taking some skin, and this was normal human skin. By the way, we get our skin ethically. We don't go around chopping people's skin off. We request it ethically, and we normally get it from doctors that are removing foreskins. Okay. And we use that as a very good model of normal human skin. So this is the dermis. When you take off the epidermis, the second picture, when you take off the epidermis, you just get this white, looks a bit fatty, but it's just the dermis and the underlying hypodermis. What it is on is called a floater. And a floater is literally floating on the liquid that is actually feeding the skin. Okay? And so we can actually culture them like that in the lab. And then that ring in the top left, we actually add cells into. So it's a cylinder that we placed onto the dermis, and it is all the epidermal cells. So we added the keratinocytes and the melanocytes in that little circle on the dermis, and you can see we're still floating it. And that is the result after about a week, after about 10 days on the dermis. And so we can see that we're slowly starting to get the keratinocytes and the melanocytes back there, pigmented. And then, over time, after about another week, we get a highly pigmented area on the dermis. Now, this whole story is a three-dimensional reconstructed skin, because we then took it and we sent it to our histology lab, where we sliced it down the middle so that we can actually look at it from the side. So that we want to see whether we've actually reconstituted a skin or not. And that's the picture, okay? That's the picture. The dermis, which we had over here, and these are the reconstituted cells that we put in. And in fact, I haven't got the other picture, and you won't be able to see it on here, but if you stain that for the specific cell types that we're interested in, so if you stain it for melanocytes, you'll see that beautifully the melanocytes were sitting all along the basement membrane, all along the basal area where you would normally find them, and the rest of it were keratinocyte layers. So we were very happy that we could reconstitute an epidermis. This work is not new. They do it in America, they do it in Europe, they don't do it in South Africa. We probably the only lab. They've now started with it in a Tygerberg lab, but we want to progress from not only the co-cultures of cells, but also to the three-dimensional reconstruct that we can actually put back. And I was chatting to a gentleman this morning. The application of this is vast, not only to the burn patients, but also diabetic patients, who develop ulcers and that need skin replacement. We'd be able to apply this, and of course, trauma patients that come in that have gunshot wounds, etc., where they need a replacement of the skin. Of course, this doesn't happen overnight. It takes some time, so we sort of can work with the patient. So the initial trauma patient has to be healed as soon as they can. So it doesn't really apply that much in that sense. But certainly the diabetic patients and the burn patients and any other patients that need over time, where we can reconstruct their skin and restore their color, it would be fantastic. So that's a little inkling into our research. Of course, this needs a lot of time, needs a lot of effort, and needs a lot of money. And we got the first and the second bit. We're still looking for the third bit. So let's now go to cancer. So we spoke about cancer in general yesterday. We then focused in on skin cancers and on melanoma and non-melanoma, the carcinomas. I wanted to leave you today with the 10 golden rules of skin cancer, particularly focusing on melanoma, but skin cancer in general, okay? Remember that melanomas are potentially fatal if not diagnosed early, okay? So the one thing to remember is that, as I said yesterday, that melanomas are tricky because they grow like icebergs, right? What you see on the surface of your skin speaks nothing to what may be happening underneath the skin. And remember, we said that they start to grow in a radial direction first, but then very quickly they go vertical. And when they go vertical, they go aggressively vertical to try to get down into the dermis, to try to hit a blood vessel. And these cells are quite remarkable because of late, the research that is coming out has shown that they don't need to grow that fast towards a blood vessel. They just send signals that make the blood vessel grow towards them. Okay? And so that is also one of the hotspots of research currently. So if diagnosed early, the best treatment is still excision, is still just to cut it out, okay? They can cut it out and you can live a long and happy life. See your doctor, dermatologist immediately if you become aware of any changing moles, and we already spoke about that, any changing moles or new irregular patches. And we said, take a look occasionally at your back, take a look at areas that are heavily sun exposed. By the way, I did get a question which I'm not probably going to come to in the question session, but I thought I'd just answer it. It was a question about when you're sun exposed, you may get a rash, or you may get, for example, when I play golf and I'm in a short sleeve, I get very itchy on my arms, and that is a simple response of the immune system to the overheating of your skin. So if it doesn't, you may realize that it's tingling, but the immune response can also respond to make it a bit itchy. So that is a good sign to you to know that you've exceeded your MED, which we now all know, right? And so very often, if you do have moles or nevi in the areas that you know are going to be heavily sun exposed, like your shoulders and your arms, it's a good idea to keep a watch on them and to see if there are any new ones that come up. Obviously, avoid sunburn. And I said at the start of this lecture that I challenged you to share this information with someone. Please, folks, we all have family, and we all have younger generation family. I'm forever telling my nieces and nephews that it is not a great idea to sunburn, right? It is not a great idea to think that is going to give you a wonderful tan. You are left with a tan, but you're also left with a serious damage of your cells, and particularly up to the age of 18 years old. You can you can do serious damage to not only the melanocytes but also the keratinocytes. We already know number 4, avoid sunbeds at all costs. Always apply an SPF 30+ sunscreen before sun exposures. So I can replace SPF with whatever number, okay? The point here is to put it on before sun exposure, and we spoke about that, right? At least half an hour before. Avoid sun exposure completely between 11 and 3. This is not a joke, particularly in Cape Town and South Africa. Between 11 and 3, it is particularly high irradiation outside. So if you can, of course, some tea of times are a lot later, and you cannot avoid it. But if you can, then avoid it between 11 and 3. Wear appropriate sun protective clothing. And I told you the story, for those who may not have been here, but I'm sure you did, of my sister's kid who got a costume. And she paid a lot of money for it. It was a sun protective costume. And as I held it up in front of my UV light with my goggles on, and the UV light just shone straight through it against my goggles, which means that it was not UV protective. Okay? So when you buy clothes, and particularly costumes for little kids, make sure that when they say it is sun protective, what do they actually mean? And this is where they get very angry with me as well. What does sun protection actually mean? If it's a particular weave that is sun protective, that is protecting you, wonderful. But very often, particularly very thin material, has to have a particular type of material to be UV radiation protective. Okay, avoid excessive sun exposure. We know that, okay? There are quite a few materials that are underwritten by the Cancer Association. Those materials have been tested for UV. I, in fact, know the lab in Pretoria. I know the head of the lab in Pretoria that does the testing. So that you can be rest assured. If anything is underwritten by an association that is relating to cancer and anti-cancer or anti-UV, etc., then you can be rest assured that it is a pretty good material.
Would they give it on their website?
They would, yes. Yes. You could go look there. Yes.
Just be very careful with the Chinese products.
Yes.
They say it's actually just a total fraud on
Yes.
the Cancer Association.
Absolutely. And so that's a very good point. The point is just be aware of some Chinese materials or some Chinese knockoffs that they may even write cancer there. They very often spell it incorrectly, but they may write it even so that they actually get the sale. And it is not by any means underwritten by the proper organization. So just point 9, early melanoma is very much a curable skin cancer. The earlier it is diagnosed, the better it can be managed. And then lastly, even if you are doused in sunscreen, do not stay in the sun longer than you have to. And also remember to reapply, and also remember that your sweat, so even if you use the SPF 30 or your SPF 50, remember what I said earlier in the week, that your sweat neutralizes it, washes it off, water, salt water, chlorine in the water, all of those factors neutralize it. And so you need to reapply. Oh, sorry, the last line is even doused in sunscreen, don't stay in the sun longer than you have to. Okay. The one before, early melanoma is very much a curable skin cancer. The earlier the melanoma is diagnosed, the better your curable rate, basically. Okay, so those are the 10 rules that generally are associated with particularly melanoma, but most skin cancers. I just want to touch on, as we wrap up the lecture, on treatments, and then I want to finish up with completing the questions that we had. So the treatments for skin cancer, we know the gold standard is surgery, okay? We remove it, cut it out, physical removal, the most successful treatment. Very often, because of the margins and because we don't know how far the tumor has necessarily progressed. So as the surgeons go in, as I said, they will cut out at least 2 or 3 millimeters more around the tumor to get rid of it. And some surgeons are highly conservative, so they'll go even further. What would generally be suggested is the use of chemotherapy in association with the surgery. And so you go on a bout of chemotherapy. Today, the chemotherapeutics they work remarkably well. I remember in my father, who had cancer many years ago, probably 30 years ago, 35 years ago, they never knew the dose of chemotherapy to give him. And so they just gave him a dose which they thought like that and would inject it. Well, they nearly killed him, really. I mean, I've never ever seen somebody go green from chemotherapeutic drugs and just lay there as if he was dead. Fortunately for him, the dose that they gave him killed all his cancer cells. And so he survived for another 35 years after that. But these chemotherapeutic drugs are designed to kill cells. Yes?
A friend who has melanoma, and it wasn't caught, perhaps too early, was told that...
I'll repeat it.
The melanoma does not respond to chemotherapy or radiotherapy.
Okay.
But only the new drugs.
Okay. So the point is that melanoma and certainly quite a number of cancers we now know do not respond to chemotherapeutic drugs. Or radiotherapy. So now I will add to that why they don't respond. Okay, and this is the most scary thing about the cancer cells, is that cancer cells learn from what they're exposed to, and so they become resistant to particular doses. And so you remember I said to you that they grow as one cell. If you can catch it as one cell, you kill it. Fair enough. But as they become clonal and as they grow into a tumor, each of those cells in the tumor are responding differently. So what will happen is if the dose of chemotherapeutic drugs do not wipe out the entire tumor in one go, you have a population of cells left that have effectively become resistant to that particular dose, okay? And so the next time you get the dose, they may up the dose slightly. You then wipe out 80% of the next tumor that has formed. The 20% left is now resistant to an even higher dose. And so it goes on if you do not wipe it out completely. And so that has become one of the most scary bits of research and information that we've found, okay? And so it immediately jacked up the researchers to try to find alternative methods beyond chemotherapy and ionizing radiation, okay? The problem with the chemotherapeutics is that we cannot increase the dose much more because they are designed to kill cells. And so you're not only killing the tumor cells, you're also killing your normal cells, okay? And so, and they are designed to kill fast-growing cells. And so any cells that divide at the same rate as the tumor at that moment in time are going to be killed. The slower dividing cells will be spared. Fortunately, the majority of your the majority of your cells in your body are slow dividing and not as fast. However, the fast dividing cells are the cells in your hair, for example, and the cells in some of your organs. And so why your hair actually falls out is a combination of the chemotherapy not only killing the melanocytes and the nourishing cells, but also killing those cells that are fast growing, okay? Nowadays, we have additions to the chemotherapeutic regime that they will add where you don't even get nauseous anymore. And they know the types of chemotherapeutic drugs are much more effective and much less toxic these days that they found. So watch that space. But that is why they become resistant. So ionizing radiation works in a similar way in that you are directing an ionizing radiation source towards the tumor. And basically what you want to do, in this case, it is more effective because it is not the complete environment as well. You can direct it quite specifically to the particular area where the tumor is. And what they would normally do is they would remove the tumor effectively, and then they'd give you ionizing radiation of the area, so that whatever cells are left that we may have missed to remove, it either kills or stuns the growth of the cells. Obviously, you cannot get away from, the underlying tissues affected, the immune system is affected. That's just the consequence of the treatment. One of the newer treatments at the moment, and something that my lab had worked on for quite a number of years, is the use of photodynamic therapy. Photodynamic therapy, in a nutshell, is using a compound that can be activated by light. So the compound, if you inject it in a particular area, does nothing, is not toxic at all, until you shine a particular wavelength of light on it. So it's a photosensitive, photoactivating compound, and there are quite a few. There's actually only 2 or 3 that are FDA approved, and they work very well for squamous cell and basal cell carcinomas. They do not work that well for melanoma as yet, but that is also in the pipeline. But for basal and squamous cell carcinomas, you rub the cream with a compound on over the basal cell or squamous cell carcinoma, and interestingly, some of the photosensitizers, some of these compounds can be activated by UV light. And so in Germany, for example, at this one hospital, where they get loads of basal cell and squamous cell carcinomas, they rub the cream on, they leave it for half an hour in the ward, and then they put them into wheelchairs and they wheel them up onto the roof of the building. And they expose them to the sun for about half an hour to 40 minutes, and the compound is activated and kills cells very effectively, okay? And that's why you can also limit where the area is by where you put the cream. So that's photodynamic therapy. It's a very effective therapy. It is also used to identify tumors, because the tumor cells take up the compound a lot faster than the normal cells surrounding it. And the compound, if you shine a particular light on it, will fluoresce. And so they've been using it in brain to diagnose the sizes of brain tumors. They just inject it into the blood vessels around the tumor. The photosensitizing agent is taken up by the tumor cells, very much so, very radically. And then as you shine the light on it, they switch off the theater lights and they bring a UV light over the brain. You can actually see the demarcation of the tumor. So they can actually go in and mark it and actually remove it. So that's photodynamic therapy. And then the last and the most recent and the most exciting development, particularly for melanoma patients, is immunogenic or antigenic therapy. So in a nutshell, again, immunogenic, we want to use the immune system to be effective in killing the cells. Your immune system recognizes certain markers on cells. We call it antigens, right? Because these cells produce antibodies. And an antibody is very specific. And so what the researchers have done is that they've identified specific antibodies or specific antigens, specific markers on melanoma cells. And so with that, because those are specific markers, we can now generate an antibody to that marker. so that when you throw it in the body, it goes directly to that marker, okay? That will get it to the cancer cell. Then you link that antibody, which is now your directive, you link that antibody to an agent that will actually get into the cell and kill it. And so that has worked exceptionally well for now. It has just been a year ago been passed by the FDA for clinical trials in America. It's evidently working phenomenally well. The problem is that as we get something that is so specific, right, very soon the cell realizes that it is under attack, and the cell has the ability to change its markers on its surface, okay, or to truncate it, to change, to break it up. So what you do is, if you've got one, the number 1 on your head as a cell, and that's your marker, the cell itself realizes very quickly that number 1 is not a good marker because we're dying, right? And so it'll change it to a number 3. And so you can throw as many antibodies as you want at that cell, it will not see number 3 because you've got number 1 antibodies, okay? And so even though we have the breakthrough, it is still going to take quite a number of years, I'm sure, my entire lifetime still probably, to completely eradicate cancer as a disease. Okay, so I want to finish this morning's session and this week by not leaving you disappointed that I did not finish your questions. So we answered those questions yesterday that I put the green ticks on. It will be in your package so you can see it. I just carried on. I just transcribed the rest of the questions onto the slide. So the question was, lots of squamous cell carcinomas and basal cell carcinomas can be removed with a cream that basically exfoliates, kills the upper layers of the epidermis, much the same as a chemical peel, okay? The answer is the next sentence, sorry. The answer is that this is fine as long as the basal dividing cells are not affected. So very often, well, right now, the dermatologists have a very effective cream. They're normally corticosteroid based that you can actually rub on or that you can inject systemically for basal cell and squamous cell carcinomas. They can rub it on. It will eventually kill the cells. Unfortunately, it also kills a little bit of the surrounding tissue, but that will heal. So we don't mind that. And they normally, if the basal cell or squamous cell carcinoma is on the verge of something that they don't like, they will excise it, right? That's generally the way they go. Otherwise, they will debride it, so they will just scrape it. They can use liquid nitrogen, or they can use the cream. It effectively works like a chemical peel. So you're basically killing or removing that layer of cells that actually has the carcinoma in it. You must just make sure that the basal layer of your epidermis, which are the cells that actually replenish the rest of the epidermis, is not overly affected, even though the cells on the side of the lesion will eventually divide enough to cover. You will either scar or you'll take a very long time to heal, okay? Right. Self-tanning creams. Is the MAD consistent for all parts of the body? So self-tanning creams, just a point on that. We spoke a lot this week about the ability to stop pigmentation, right? In the case of vitiligo, sorry, I'm sitting right there. In the case of vitiligo, we know that the melanocytes are dying. In the case of skin lightening creams, we actually stop the pigmentation by affecting that pigment factory, right? In the same way, we can add stuff to the melanocytes to activate them to produce more pigment. And so yes, you do have the ability, and the cosmetic houses, the wellness houses will be able to do it for you. They do have the ability to increase pigmentation as well. One of it, and I'll just mention this, one of it is a little hormone called melanocyte stimulating hormone, okay, MSH. And there are different forms of MSH. You get an alpha form and a beta form, but it is a natural hormone that we produce. It is formed as part of the proopiomelanocortins, which is the group name for the hormones. And MSH works as a very effective tyrosinase activator and hence pigment maker. So the self-tanning creams that they sell has a little bit of MSH in it generally. Or right now the market has exploded with compounds that actually increase the tyrosinase activity, that increase the melanocyte activity, all of these derived from natural products. One of them, believe it or not, is licorice. Okay? Licorice from I think the licorice tree is some of the compounds in licorice actually increases or enhances pigmentation. Just another fun fact that I forgot to mention is that tyrosinase, the enzyme that generates the pigment, is also the enzyme that you find in fruit. And so your fruit going brown or, eventually rots, but the browning of the fruit is from exactly the same enzyme, tyrosinase, that your skin has. So, is the MED consistent for all parts of the body? Obviously not, because not all parts of your body is sun exposed. So yes, if you're interested, and I mean, we were talking about the sun exposed areas, if you plan to expose a non-sun exposed area to the sun, then you would have to work out that particular area's MED. Okay? The dangers to the skin from tattoo, yes.
Does that mean you can use self-tanning?
I
mean, from a chemist or
yeah. Yes. There are lots of other potential compounds that they include in it, but they generally are compounds that increase absorption, compounds that stabilize the cream so that it doesn't go off, over time, etc. And compounds that reduces the oxidation of the cream. So in general, but the key ingredient there would be something that activates tyrosinase. And believe it or not, they may even add some tyrosinase into the cream as well. You won't know that because it won't be on the label as tyrosinase. It'll be its enzyme number. So you see a E0101 or E15132. That's the enzymes that they add into the creams. Dangers to the skin from tattoo dye? Not really. Your immune system is a pretty good surveillance mechanism around anything that you insert below the epidermis. And so if there's anything, you'll develop maybe a rash or a little bit of a reaction, but it won't be highly cytotoxic. Of course, you have to make sure that the tattoo artist is working sterilely, right? Make sure that he hasn't used the needle on the dude before you, and now he's using the same needle. All right. So that is really, and then the sun exposure, and I would presume that the sun exposure on the tattoo dye was the question. These dyes, they may fade over time, but they don't really change into anything cytotoxic as far as I know. Okay, how do steroids affect the skin? Well, steroids are there to dampen the immune system, and so part of the effect that they have on the skin is interesting, and that's why the dosages are so important. If you increase the steroid dosages, you tend to thin the skin, okay? So you tend to reduce the proliferative ability in the basal layer, and so whereas you may get 3 layers over a period of say 4 days, you may get 3 layers pushed up, now you're only getting 1 because your steroid level is so high. It will obviously recover. Steroids is one of those things that you don't overdose on, obviously, but it also washes out. So as it flushes, the concentration reduces, your cells realize that, and they return to normal. So it does affect the skin in that way, tends to. So this was in provide the lecture series as a PDF package to the summer school. It'll go on the website, so keep your eye on the website. Obviously, give them a few days. It is not going to appear on Monday. Okay, they need quite a few days to put all the lectures and everything together, all the packages. But it will be on the website. I will also include, as I promised yesterday, the links for quite a few of our publications on that. And obviously, you have my details. So my details, and really, I want to encourage you to, if you can contribute or keep in contact in any way via email is probably the best. I don't tend to give people my cell phone numbers, sorry, but and I will certainly get back to you. I may not get back immediately, but I certainly pick up the emails, and I'm on my email just about all the time. So thank you for that. What I want to share today is a little bit of the HOPE research that we're doing, linking it to vitiligo, burns, and cancer. And so we'll talk a little bit about that. The one question that was raised was the glare off the front screen. Are people struggling to see my texts on the screen because of the glare? Unfortunately, the problem is we don't have a dimmer on these lights. The age of this lecture theatre, which is probably older than I am, does not allow us to dim these lights, which we tried. So we'd have to switch off the entire lights in the whole lecture theatre, and then you won't be able to read, or you won't be able to write, or read what you're writing. So if you don't mind, we are going to leave it on, and then you can just, if you do have a problem. By the way, the writing on that tunnel is blurred. Okay, so there's, and I wanted to read it to you. It's a wonderful quote. The light at the end of the tunnel is not an illusion. The tunnel is, and I thought it's a great quote to kick off this morning, because we often think that it is a lot more difficult to try to solve something with just a little bit more thought. We actually have the solution. We just have to sort of get into it and try to solve it. Then there's been very good news, and this came across my email yesterday, that Virgin Active is saying goodbye to their sunbeds as of the 1st of April. I'm sure it's not an April Fool's joke. I will check though. But from the 1st of April 2017, they're removing all their sunbeds from all the Virgin Active clubs all over South Africa. And they will no longer have indoor tanning facilities. So that's for me, not only to share a lot of what I'm very passionate about, but also to hear you starting to skin think, which I translate into skinking. But I'm glad that you are skinking at the moment, because I would like you to leave here with, my one aim was to make you more aware of what is out there, of our own skins obviously, but more importantly, I really would like you to translate whatever you've learned, whatever you've grabbed, whatever has grabbed you this week, to other people. And so the challenge is laid down to you, just to share something of what we did this week with one other person outside of this room. And so whether it is your grandson, your granddaughter, your daughter, your son, your partner that may not be here, your grandmother, whoever, just share something that grabbed you this week that you may not have known, or that you did know but you were reminded of. And so the aim was really to just enlighten you a little bit more and to get us thinking. So thank you. I've also included, so let me just tell you one or two technical things before we start. the one thing is that because you're generating stress on the skin in that area of abrasion, and the melanocytes, which are suspicious anyway and susceptible to dying, they tend to die. In the Indian community and in the Muslim community, interestingly enough, when they do have vitiligo, it very often starts under their neck, in the neck, just under their chin, sorry. And what we found was that they were tying their scarves quite tight around their heads, and that the buckle was over here. And that shaving on the underside started the vitiligo spot. And from there, it spread. So this little boy came to us, and we decided via my lab that we would conduct a study to try to get his cells, his normal cells, clone them, and then add them, return them to the vitelliginous areas. Okay? And so it was quite an ambitious thought, but we thought that we were skilled enough to be able to do it. So we brought him into surgery. We took a couple of biopsies from a normal area, and what we normally do is we take a biopsy so that you don't even see it. It's a 2 millimeter biopsy, so it's tiny. Yes, one for us. So this morning I want to kick off with vitiligo again. You've heard more than enough by now about vitiligo, but I want to tell you the story of how we managed to change a 12-year-old's life. This is the son of a colleague of mine, and he has vitiligo, and he has symmetrical vitiligo, so you can see it's on both knees. He's 12 years old, of Indian descent, and very active little boy, beautiful little boy. He plays soccer, he plays cricket, he plays rugby, just about anything that he can get his hands on, he plays. Unfortunately, because of his vitiligo, lots of his areas are under high stress, under high stress in terms of abrasiveness. And so he gets vitiligo, and his vitiligo started as a small spot and then continued under the more abrasive areas. His knees, his elbows, his hands, and his feet. And then he started getting spots on his neck as well, where his shirt collar used to rub against. And those are very often the types of issues that activate vitiligo.